And just to make sure we've worked your brains enough today before we finish, have a go at this question. If it helps, think of apparent magnitude, think of brightness or intensity there. Okay, so it takes a fair bit of detective work just to work out what's going on here. We know we've got a binary system, so that means we've got two stars that are orbiting each other, so they're orbiting their centre of mass, and we can see that they must be of different brightness. We've got this maximum brightness here, and so that must be when we're seeing the light from both stars, and so that's when they're sort of side by, they're not blocking each other. And then here, where we've got the biggest drop in brightness, that needs to be when the dimmer star is blocking the light from the brighter star. And then the smaller drop, that needs to be when the brighter star is blocking the light from the dimmer star. So that's what's going on. Okay, so you've got maximum of 4 marks from a huge list of things you can say. So let's go with, for a mark, the two stars have different brightnesses. For a second mark, most of the time, most of the way around, you can see both of them, and that accounts for the maximum brightness. For the third mark, at A, the dimmer star is in front of the brighter star and blocking the light from it, and at B, the brighter star is in front of the dimmer star and blocking the light from that. There we go, there's our 4 marks. And the second part of the question is a Doppler shift question, a redshift question. So here is the V, that's the speed that the star is moving relative to us. And there's the lambda, that is the value of the wavelength if the star wasn't moving. Okay, so we're first going to work out what the change in wavelength would be for it moving towards us or away from us at that speed. And so first mark is for substituting the numbers in, and the second mark is for finding the change in wavelength, and the third mark is for saying that the maximum is the wavelength plus that, and the minimum is the wavelength minus that for the third mark.